So let's have a look at some basic probability sampling methods. Remember, probability sampling is the same thing as saying randomized sampling, so we want to have some kind of randomized effect, but that means respecting some kind of probability structure, probability pattern. So, for instance, when we talk about a random sampling method, that has a particularly specific meaning. What we mean is that our sampling method is done in such a way that each member of the population has the same probability of being selected. Okay? Now, certain randomization methods don't achieve that, so they are not true random sampling methods, but they are randomized in the sense that every individual has a certain known probability of being selected, and we may know already in advance that some people have more probability of being selected than others, and that's okay. But want to be aware of the fact that some people have different probabilities, if they do, and what those probabilities are. But if we're talking about a random sampling method, we mean that every member of the population has the same probability of being selected. Now, there is another more specific way of selecting a sample, which is called a simple random sampling method. And what that is any method in which, in fact, not only each member of the population has the same probability, but each sample of a certain size has the same probability of being selected. So this is a bit more stringent kind of condition. So not only we want to be able to select each person with equal probability, but also each combination of subjects with equal probability. This is a sampling method which is ideal in statistical analysis, but which in practice you're never going to find. Okay, so this is the ideal toward which we strive, but it is not the way it actually happens. Now, how do we achieve these kind of methods? Well, one common method to do it is to put names in a hat and then mix up the names and pull out the names that or as many names as you need. Now, this is the old-fashioned way. A more modern way to do it is by using random number generators. And that's the way we do it normally. So notice that when we do this, pretty much everyone has the same probability, and every combination of people has the same probability of being selected. But again, this, as you're going to see, this is not going to happen much, especially in clinical research. So what else are we going to use? Well, here is another interesting method of doing sampling. It's called systematic sampling. What we do with this method is we do the following. First of all, we obtain a list of the available population. By the way, I should make a little aside here. When we're talking about probability of being selected and so on, we always refer theoretically to the whole population. But even that is a little bit too much, and in practice all we can deal with is the available population, the part of the population that we have access to. Okay, so everything we're going to say from now on refers to the available population, and one important aspect of checking if our sample comes from the population is also to make sure that our available population is in fact a proper representative of the total population, and therefore it's quite important to describe the available population and the target population very clearly. Alright, so let's say we have a list of the available population. What we're going to do is we're going to make this list we're going to order it according to some factor which is totally unrelated to what we're studying. Quite often alphabetical order is what is being used. Okay? Then what we do is we pick a number as what we call step size. Okay? So let's say we want to pick every 10th person or every 5th person or every 100th person. Okay? So what we do is we start from a certain place in the list, and then we're going to pick every nth subject in the list. Okay, so here is a visual representation of what we're doing. So let's say we're going to select every 5th member of the population. So we begin by selecting just one member at the beginning of the list. Okay, and then what we're going to do is we're going to select every 5th after that. So here is the next one, then we count 5 more, and there is the next one, and we count 5 more, and we get another one, and so on until we get to the end of the list, or until we have enough people for what we need. Okay, so notice that this method, again, because we're ordering the list according to some factor which has nothing to do with our population, it gives everyone the same probability of being selected, and it does not, it will not generally exclude any important subgroups and so on. However, this is not a simple random sampling because not every combination of people has the same probability of being selected. In particular, for selecting every fifth person, two people who come one after the other in the list have no chance of being selected together. But again, that's still a randomization. We're trying to exclude any bias. We're picking randomly from the list or systematically from the list. Randomly in the sense that we don't know who is on the list at any particular position, right? Remember, the order is independent of the factor we're studying. But that's where the randomness comes in. All right, another probability sampling method which is used quite commonly is called stratified sampling. Here the idea is again to look at our desire to not exclude any subsets of the population, any subgroups of the population. So what we're going to do is we're going to divide the available population into relevant subgroups that we call strata. Okay, so these subgroups are subgroups that we want to make sure we are going to get someone from. Okay, and then we're going to decide an appropriate sample size for each of these strata, and we're going to collect a proper sample of the desired size from each stratum. Okay, confusing? Let me give you a visual. Okay, so let's say this is our sample. These are available population, sorry, not a sample. This is the available population. Those are the people that we can draw from. And let's say we want to make sure that we get some people from that subgroup, and some people from the middle subgroup, and some people from the last subgroup. So what we're going to do is we're going to identify those three subgroups, and we're going to select in some proper way, some random way, maybe putting the names in a hat or doing a systematic sampling. We're going to select some people from the first group, we're going to select some people from the second group, and we're going to select some people from the third group. And again, each one of these groups is called a stratum. So in this way, we make sure that we obtain enough people from each subgroup, and we can also decide how many we want from each subgroup so that each subgroup is represented in the proportion that we want. Okay, so this is called stratified sampling. The last one that I want to show you, again because it is used fairly commonly, is called the cluster sampling. And in this situation, what we do is we have an available population once again, and what we're going to do is we're going to divide that available population into small clusters. The way we're going to do it is by constructing clusters by putting together subjects who are close to each other. And the proximity, the closeness, could be either in space, so they live close to each other, they are in the hospital close to each other, or in time, they come to the clinic close in time, close to each other. So maybe everybody who comes on a Monday or something like this. So what we're going to do is we're going to divide that available population into groups, and then what we're going to do is we're going to select a random sample of clusters. Okay, so we're going to say, all right, we're going to pick those. Okay, and then finally we're going to collect data from each and every subject of the selected clusters. So this is called cluster sampling, and it has a certain amount of randomization in it, but also notice that it involves a certain amount of convenience in the sense that we're going to collect information from people who are close to each other, so it's going to make it a little bit easier for us to collect the data. Okay? Alright, so those are the basic methods. There are more, of course, like everything else. We're just skimming the surface here. There are very much more complicated methods of doing it, and there are other criteria to look into, but these are just some of the basic ideas about probability sampling. Now, what does probability sampling allow us to do? It allows us to control for bias. Again, remember, control, not totally avoid it. It allows us also for a measurement of variability. This is a technical point. I don't want to dwell too much on it, but an important part of doing inference is to know what the variability in your population is, and probability sampling allows us to have a good control over that. Therefore, it allows us to make inferences. Okay? But the problem is that it requires a complete list of the population, even if it's just the available population, and that list may not be available. And that means that we're going to need more practical methods to do some sampling, which somehow get away from the need to have a complete list of the population. Some of these are called non-probability methods, and they're dangerous, and we're going to look at those in the near future.